Chapter 12, Lesson 7. This lesson, the final lesson of the chapter and of Geometry A, so you should be excited here, is all about dilations. Now I know you guys have done dilations before, but probably one of the things you might not have done is actually drawing them. So that might be the only really new piece here. But just kind of a review, I guess. What is a dilation? A dilation is when you do a transformation that changes the size but not the shape. So size, but not shape. The best example, or the easiest example, I guess, not best, but the easiest example I can give you is two paper clips. I mean, if you look at these two paper clips, they're not the same size, but they're definitely the same shape, and they perform the same function or duty. So basically what's happening is it's just making it bigger or making it smaller. Okay, and you can kind of see down below here, if you kind of look down, you'll see those vocabulary words down there. So examples 1 through 4. If you look at example 1, do you think this was a dilation? Did it get bigger or smaller? No. I mean, it looks more like 1, it got turned, but also then, I mean, it kind of got rearranged. You know, the sides are not necessarily as proportional as they should be. So number 2, we'd have to say no. The turning is what's going to kind of really make it say no. On number 2, do you think this is a dilation? Yep. Basically, again, I mean, it looks like it either just got bigger or it got smaller. Okay. How about 3? Is 3 a dilation? No. Because, I mean, it physically kind of almost, you know, is tall and skinny to now really short, where the bottom almost looks like it's the exact same length. So really what they just did was they changed the sides, the 2 sides, but they didn't change the third one proportionately. You're going to kind of keep hearing me use that word proportionally. If these 2 got smaller, then the third one better as well. It's sort of like this. I mean, these significantly changed, but then these didn't change as much, so it's not proportional, okay? How about 4? Do you think that's a dilation? Yeah. Now, whether it got smaller or bigger, we're not 100% sure until they tell us the original, but it definitely got bigger or smaller. All right, a scale factor. A scale factor basically means how much bigger or smaller did it get, okay? So did it get 10 times bigger or half? Now, I don't know exactly why, but your book uses the abbreviation K. So if you ever see this letter K, it's standing for dilations. Your book likes the word enlargement, but sometimes I've heard it called an expansion. If you're going to get bigger, you better be bigger than 1. If you're going to get smaller, then you have to be between 0 and 1. Now, negatives. Some kids will wonder, what do negatives do? Negatives actually turn it. So if you do a negative 2, it's going to basically turn your figure and make it twice as big. So the number is bigger or smaller. The negative will be the turning piece. So you don't want to worry about negatives. Identity means that you don't change it. So if you walk down to the copy machine and you try to make a photocopy, it's actually going to do it in percents. So it's 100%, which is a scale factor of 1. Okay, so that would mean it wouldn't change. Now, the center of dilation. The center of dilation is where does the enlargement occur. What I've often sometimes seen is teachers will walk down to the teacher's lounge or the copy machine area, and they'll take a picture. Like this is from the last lesson. They'll take a picture and they'll say, I want to blow this up. Well, what they'll do is they'll put the paper down and it'll get cut off. And they're like, what happened? Well, the copy machine is doing the center right dead in the middle of the paper. So maybe you want to blow this one up. Well, what it's doing is it's taking the center and then it's blowing up from the center. If your figure is on the edge of the paper, chances are it could get cut off. So if this is the item that you want to enlarge, when you go to the copy machine, you have to put that in the middle. You don't want to line the paper up, you want to put the figure in the middle. So whenever you hear the word center, they're talking about kind of like where does it kind of like begin? Where does that expansion occur? Now that seems challenging or weird, but it's not really that hard. if you look down at 5 and 6, we have to find the center and determine the scale factor, okay? So these should be labeled on your paper. I think I forgot to label them on mine, but I'll go ahead and label them right now. So they should be already pre-labeled on yours, okay? What you can do is notice the prime, so you can tell this got bigger. So we know it's going to be bigger than 1, okay? So what we do is we just take a ruler and we just measure. So this is about 2 centimeters, and this is about 0.9 centimeters. If this thing got bigger, if this is an expansion, then we just go 2 divided by 0.9. And so 2 divided by 0.9 is about 2.2, which means this got about 2.2 times bigger. So this would be our scale factor. Now, you should be able to measure any of these sides, and when you divide it out, you'll get this number. So if you don't believe me, I'll kind of try this. Whoops, yeah, let me just measure this. So that's about 0.6, and that's about 1.3. If you go ahead and do 1.3 divided by 0.6, you get 2.16 repeating, which notice that's about 2.2. That's not bad for the human eye, and remember, I'm an old lady, so that's not too bad for me reading this ruler, okay? So that's how you find the scale factor. To find the center, you simply connect the points. And what you should notice is they will all go through the same point, and that's the center. So why don't you go ahead and pause it here and try number 6. Alright, hopefully you tried number 6. Let me quick work it out here. If I measure this, I get about 1.8. Now if you measure it and you're a little bit off for me, I'm not going to mark you down because I realize, you know, it is definitely hard to tell a little bit between, you know, 1 to 2 millimeters, that sort of thing. So please, you know, don't worry about just a little bit off there. Sorry, I forgot to write these down, but hopefully they're on your paper. We can tell that it's getting smaller, so we obviously have to put the smaller number on top. If you put the larger number on top, then you'll just have the reciprocal. So it looks like it's about 0.5. So in a way, that's about, you know, half as big. Okay, but I'm just looking for this number right here. Then to find the center, you just connect them. Now hopefully you realize you don't have to connect all 4. If you want to, you can. But if you notice that as long as you do at least 2, you'll find the center. If you do additional ones, I can kind of just show you one more. Notice, get it right there. They still go through the same. So I usually just connect 2. But now you should know how to find the scale factor and the center, okay? So the next thing we have to do is kind of work backwards. Now we're given the center and we're given the scale factor, okay? And this should be corrected on yours as well. I notice it is not on mine. I apologize. There we go. But what we have to do here now is we have to draw it. So 7 and 8 are just a little bit different than the 2 you just did, okay? So what we're going to do is, if this is the center and we're getting bigger by 3, we're going to have to take this thing and we're going to have to basically go out, okay? So what we have to do is we have to take our ruler and we're going to measure this distance, okay? So we're going to go, so it looks like it's about 1.5, okay? If this is 1.5, I have to multiply that by 3. So 1.5 times 3 is 4.5. So that means I have to go out to 4.5, and that will be my new R. So what I've done is I've taken this distance and I've timesed it by 3. But you're always measuring from the center out. And then you have to do that for all of the points. So then you do the same thing for S, then you measure. Now the distances are going to be different, so you always have to measure. This looks like it's about 3.7. So about 3.7 times 3 is about 11.1. Woo, that's way over here. So that's way over. So there's my S. And keep going. Do the T. Now that should be the same measurement. Oh, that's the same. And then do the U. And again, that should actually be the same as the R. So technically you only have to do 2 measurements, but you still should check just to make sure. Yep, that's the same. Whoops, that's U, not T. Sorry. And then you basically just make your rectangle. Somehow I got a little, oh, my line here isn't super straight. Somehow I got a little angled on that one. Yeah, it looks like my line, was I not super straight? Maybe this figure actually gets a little bit smaller. Maybe these sides are not exactly the same. I'm not sure, I might have angled it a little bit there. It's kind of hard to tell when I'm kind of moving around up here. That does look about right though, because the original almost looks like it kind of angles a little. At first I thought it was a perfect rectangle. But you can see now, obviously this is way bigger. It's 3 times bigger, okay? So why don't you pause it here and see if you can do number 8. Now remember, it's getting smaller, so it's going to be going this way. So go ahead and pause it, which I'm going to pause it as well so I don't make this an extremely long video, and go ahead and see if you can draw that. Actually, let me show you how to do the first one and then I'll pause it, okay? So what I'm going to do, I'm going to put the 0 on the ruler here. And again, I'm just going to kind of measure. Now this one, if you don't want to connect the line, you don't have to because you're not going out. But I get about 2.8. So if I take half of 2.8, I get 1.4. So there's my C. Okay? So go ahead and do that for all of the points. I can probably do that fairly quickly here. So I get about 3.4, which is about 1.7. Guys are going to be close together, aren't they? And then that's about 4.2, which is about 2.1. And there's my figure. Alright, the final part of this lesson is about dilations in the coordinate plane, which if you remember when we just, well, a couple lessons ago, when we did translations in the coordinate plane, really that's just a fancy word for saying graph. Now, this is the exact definition, and if you kind of read through, I know it's hard to understand, but if you look at the picture, it's actually easier. Here's the original, okay? If you have an original, x comma y, you know, maybe 2 comma 3. Here is the original point. For the image, all you do is you multiply by the k. So all you have to do is multiply by the k. So this whole box kind of says that. So these are actually fairly easy. So if you look at number 9, notice you have the triangle and it says draw the image with the scale factor of this. What I think is easiest to do is take and write down the original coordinates, okay? So take each of the points and just jot them down. So there's the original. I just took it right from the picture, okay? Then what you have to do is you have to multiply by a -1/2. Now remember what we said before. Negative actually refers to like upside down. So what you're going to see is this thing is actually going to get turned and become half as big. Okay? So all we do is we go negative 1/2 times this, which would be 1. And then 0 times anything is 0. All right, Q. If we times it by negative 1/2, that would be 2, 1. And then if we do the R, that would be negative 1, 2. Hopefully I did my math right there. Once you have your points here, then all you have to do is graph them. So you just basically go 1, 0, which would be right here. Then we go 2, 1. And then negative 1, 2. And so, if you notice, our figure got half as big, but it also got turned or flipped upside down. Okay? And then notice they are using the origin. So if we were to connect like P to P and then Q to Q, notice you're always kind of like going through the origin. So that'd be sort of like the center. Okay? So graphs are actually not that bad. And if you look at number 10, notice number 10 is actually a similar question, only instead of physically giving you the graph, I've already given you the points. So what they say here is give the new coordinates with a scale factor of 2. So all you have to do is multiply basically all of these numbers by 2. So 0, 12, 8, 0, 4, negative 4, negative 4, negative 4, and you're done. So this one was even easier because they already listed it all for us. Does that make sense? All right, then the final piece of this lesson is story problems, which I know you guys all absolutely love, so what better way to end the class with 3 story problems. So here we go. It says given some applications. So a photograph has the dimensions of 30 by 35. If we enlarge it by a scale factor of 3. So we're taking this, 30 by 35 and we're making it bigger. All we have to do is times it by 3. So it would be a 90 by 105. So not too bad, right? Now, 12, if you're thinking, oh, that was really easy, 12, similar, just a little bit different. Notice now you have a picture, it's a 5 by 7, and Sue reduced it. Now they're asking you for the scale factor. So you know that it got smaller. So what do you think you're going to do? You're not going to multiply, you're going to, the opposite, divide. Remember, this dimension goes to this one, and the 7 goes to this. So you're going to divide them. But because it got smaller, you have to put the smaller number on top. So 3.5 divided by 5 is 0.7. Or, if you do the other one, 4.9 divided by 7 is still 0.7. So it doesn't matter which. You only really have to do one. Okay? But either way, K is 0.7, or if you like percents, that'd be 70%. So I don't necessarily care on that one how you want to do it. So notice these two were kind of similar, but it was a little different. So it's not going to always be exactly the same question. So for your final question here, why don't you pause it and try number 13. All right, for your final question, it says, what's the actual diameter of the actual flower? And it'd be 0.75 inches, or some people like to say 3/4 of an inch. Now, if you got that correct, you are all done, but if you didn't, let's quickly go through it. It says 4 inches to 1 inch. So you have 4 inches is 1 inch. This is like the sketch. This is actual, okay? And it says if the flower has 3 on the sketch, what's the actual? Well, there's different ways to do it. you could set it up just like that. You could go 4 over 3, 1 over x, and then you could cross multiply. So you'd get 4x equals 3, and then notice if you divide by 4, there's your answer. You could go 4 over 1 is equal to 3 over x. Notice, again, if you cross multiply, you get 4x equals 3, and then again, you divide by 4. No matter what, you're going to be coming out with 3 4s, but it just depends on how you want to set it up. But what you have to pay attention to is sketch was first, actual is second, okay? So, because some people always say 12, so you just have to be careful in how you kind of set that up. It's not always necessarily 4 times the 3. You have to sometimes, set it up proportionally there, okay? So that concludes Geometry A. I hope you are excited that you're all done with the notes and videos and all that kind of stuff. I wish you the best. I hope you do extremely well. I am here to help you, so please ask if you have questions.